Welcome to my channel. Another day, something to learn. Compound data types are data structures that allow grouping of multiple values or elements of different data types in a single variable or object. They are also called structured data types, composite data types, or aggregate data types. In programming, the most common compound data types are arrays, lists, sets, maps, and tuples. Here is a brief description of each. Arrays. An array is a collection of elements of the same data type, arranged in a contiguous block of memory. Each element can be accessed by its index. Arrays, for instance, allow storing multiple values of the same data type in a sequence, while structures and classes enable grouping of data members of different data types under a single name. Unions, on the other hand, allow storage of different types of data in the same memory location. The advantage of compound data types is that they enable efficient memory management and increase code readability and maintainability, particularly when working with large and complex data structures. Lists. A list is a collection of elements of different data types, stored in a linear order. The elements can be accessed by their position in the list. Lists are mutable, which means you can modify their content by adding, removing, or replacing elements. They also support indexing, which means you can access individual elements of a list by their position in the list. Here is an example of a list in Python. My_list equals 1, 2, 3, hello, true. This list contains 5 elements of different data types, including integers, a string, and a Boolean value. You can access individual elements of the list using their index, like this. Print my_list 0. Hash output 1. Print my_list 3. Hash output hello. You can also modify the content of the list by assigning new values to specific elements, like this. My_list 1 equals world. Print my_list. Hash output 1 world 3 hello true. In addition to indexing and modification, lists support a variety of other operations, such as adding elements, removing elements, sorting, and searching. Sets. A set is a collection of unique elements, in no particular order. Sets are commonly used to perform operations such as union, intersection, and difference. Unlike a list, a set does not have a specific order, and each element can only appear once. This means that sets are useful when you need to work with a collection of elements, but you don't care about their order, and you want to ensure that there are no duplicates. In many programming languages, sets are represented using curly braces, with the elements separated by commas. For example, in Python, you can create a set like this. My_set equals 1, 2, 3, 4, 5. You can also create an empty set using the set function, like this. My_set equals set. Once you have a set, you can perform various operations on it, such as adding or removing elements, testing if an element is in the set, finding the intersection or union of two sets, and so on. Unlike arrays or lists, sets do not have an inherent ordering, and they only store each element once. This makes sets particularly useful when dealing with mathematical operations, such as unions, intersections, and differences. Maps. A map is a collection of key value, k, v, pairs, where each key is associated with a value. Maps are commonly used to store data that can be looked up using a unique identifier. Maps are sometimes referred to as dictionaries or associative arrays in other programming languages. Maps are useful for storing and retrieving data quickly, because the key serves as an index to the value. This makes it easy to look up a specific piece of data by its associated key. In many programming languages, maps are implemented as built-in data types or as part of a standard library. Maps can be created dynamically and can have keys and values of different data types, depending on the language. Maps are commonly used in data processing, where they are used to group and aggregate data based on certain keys. They are also used in web development, where they are used to store and retrieve data for web applications. Tuples. A tuple is a collection of elements of different data types, similar to a list. However, tuples are immutable, meaning their contents cannot be changed once they are created. Tuples are similar to lists, but they are immutable, meaning that once a tuple is created, it cannot be modified. Tuples are often used to group related data together in a single object. For example, a tuple might represent a point in two-dimensional space, with the x and y coordinates as its two elements. Tuples can also be used to return multiple values from a function, or to pass multiple arguments to a function. In Python, tuples are created by enclosing a comma-separated sequence of values in parentheses. For example, my_tuple equals 1, 2, hello, true. In this example, my_tuple is a tuple with four elements: the integer 1, the integer 2, the string, hello, and the Boolean value true. To access the elements of a tuple, you can use square brackets and a zero-based index. For example, print my_tuple 0 hash prints 1, print my_tuple 2 hash prints hello. Since tuples are immutable, you cannot modify the elements of a tuple directly. However, you can create a new tuple that is a modified version of an existing tuple by using concatenation and slicing. Compound data types are essential in many programming languages for building complex data structures and algorithms. Compound data types allow you to group multiple pieces of data into a single variable. Some of the advantages of using compound data types include increased efficiency. Using a single variable to store multiple pieces of data can make your code more efficient, as it reduces the number of variables you need to declare and manage. Improved organization. Grouping related data together using compound data types can help you keep your code organized and easier to understand. Simplified code. Using compound data types can simplify your code, as you can perform operations on the entire dataset rather than having to iterate through each individual element. Flexibility. Compound data types allow you to store data of different types and structures, which can be useful for handling complex data. Code reusability. Once you have defined a compound data type, you can reuse it throughout your code, making it easier to write and maintain. Overall, using compound data types can make your code more efficient, organized, and easier to read and maintain. Thanks for watching, and don't forget to hit the like button and subscribe.